Mm-hmm.
Then yeah,
Yeah, means
then it feels
here
good.
you are able to like talk one to one, but watching video definitely it will help you to understand and all. Sometimes you may not understand also to whom to ask. Due to that, only these sessions are there,
Yes,
right? So because this is the one way you are studying through the video lectures and all. And to make it more effective, this sessions are there so that whatever you did not understand from that or any doubt is there, then how to address that. So that clarity will be getting. So slowly for all the courses, if you get this understanding, then you can go for the next level of course. Slowly you can go to the degree also. Then you will
yes,
be counted as the same as the direct BTech join in IIT, right?
yes.
This is the majorly objective. So that's why we were thinking, we thought of asking you people, only you can answer actually. So we may not be identifying correctly, but the issue, whatever it is that you may tell us so that we can try to modify that. If you something you are feeling that like no, it should not, then we can try up from our level. But
Okay.
communication
I
should be
think sometimes it be a language issue, maybe. Or
No, 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 that's not a
there.
problem.
If it is
No, ma'am, I
language
don't.
issue, if it is language issue, then in the regular video lectures, you are just watching the English language, right? And
yes,
here, no one is asking you to talk. Just like if you feel that no, in your local language or Hindi, you can talk. No restriction is there, right?
yes,
But anyhow, the communication should be there wherever you are learning, whatever it is, fruitful to you or not, to know about that. And if you have any doubt and anything, you can talk directly to us so that we can address those things.
I think a good
I
point
think they
would
should
be
release the
to send a
for
mail and ask for
yes,
the feedback from the students, like why are they
yeah.
not
What
attending and
issues
any
they are?
problem.
Like voting kind of thing. Why they are not attending?
Maybe a Google form would be better, I guess.
Yes,
Okay, I think Google Form and all, I think they tried for other students, but it was not, and means only five students filled it. That is the outcome. That is.
Ma'am,
okay,
the communication is not well established. I think it is the main one of the main reason. Like I have got information from other, like I have qualified this 26 October, but I have got I have asked all the students who have qualified this 26 October. They no
Mhm.
one of them got the mail about the Spark event. So from there, I got to know about the Spark event. Like we have not got any email, so there is a miscommunication so much. That's why I think.
Okay. Okay, then let's discuss that. I will discuss these things with the team.
Yeah.
So how can we?
I mean, one suggestion that will be helpful, like you tell team to set up WhatsApp channels. Like people are more active on WhatsApp, so from there they can easily the information can be easily passed.
No, WhatsApp is not the official channel, and it's not
No, no,
possible to.
no. I'm saying like WhatsApp has a feature like channel. So from there, today is the era of automations, and we they can set up automations for our notifications. So people are more active on WhatsApp. I think so.
Okay, let me talk about that also. Actually, what happened, do you know? Even though officially we won't prefer WhatsApp because WhatsApp is just informal communication platform.
Yeah, that would be really bad idea, man. WhatsApp.
it is
Yes,
unofficial.
No, 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 no. WhatsApp in a
I
WhatsApp there
understand
is a
saying that channel only create the channel of
ye-
WhatsApp and all the announcement should be the WhatsApp channel.
yes, ma'am. Because in channels no number is shared. I understand like that numbers are shared, but in channels only the admin can see who have subscribed, and no other people can see the other people profiles or number.
That I know. That I know. That I know. And one more thing is that in the G space, what is the issue?
I am not like the person people who are who qualified this 26 October. They are not in G space.
Why they are not in the G space? Why did not join
I
that G space?
We are not even added. I don't know why we are not in the G space.
We can access the G space, but I think the students are not very frequent on G space. Like as you said, they are mostly on WhatsApp groups, so the unofficial groups and stuff.
No, but people who qualified this, like who gave qualifier on 26 October, they are not in the G space.
I can see it.
Okay.
Me-
Okay.
you can see the Google group. The G space is a different thing.
Mm-hmm. Okay, these points I've just keep it in my mind. I'll just discuss this with the team. Then how can we address it? Let's see. So today, just I got the information from other instructors like Vishal and Akalya. I supposed to discuss about the week 9 contents summary. So just to save the time, I have just written some few things. I will discuss that thing because writing and explaining it will take again time because only 1 hour is there. So is my screen visible?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. So yeah, here if you see if we start with this lecture 1 to 8 of this week 9. So week 9 starts with the topic of this sampling rate and quantization sampling, sample and hold circuit, flash ADC, all these things. So slowly just I will talk about that. So before that, just I would like to ask you, can you tell me that whenever you are using any microphone, if the microphone, if you are using one microphone, another one is using other microphone, so are they going to interfere with each other?
Ma'am, microphones are connected to the same device.
That may be a same device but two ports.
Yes. So, what's your question?
But those device, whenever you are using, are they going to interfere, means with each other? Any interference will be there?
Ma'am, two different microphones will not.
Yes. So why it is not?
They have some certain frequency to capture a voice, and
Yes, the frequencies are different. Okay. So whenever the frequency is coming to the picture, normally we know that so before going into the detail of this, just I would like to let you know that majorly this course has no importance of these topics of signal and that your, for
communication.
example, modulation, communication, all these things has no importance, just the applications we are talking, because whatever
Okay.
major thing you have studied about the circuit, this circuit ultimately where we are going to use. Are you following?
Yes, ma'am.
Okay, so this subject is majorly on the circuit analysis.
Making
But
PCBs and kind of a circuit making a VLSI like.
not like that. Like, see, this course will give you the fundamental, for example, I will say that uh, you have
Uh,
some circuit analysis, means how to use your KCL, KVL, Ohm's law, and
Foundation basically.
uh, Thevenin theorem. and how to calculate the output voltage, input voltage, if this is, and different kinds of voltage sources are there, how to deal with that, those kind of circuit analysis you have done. These circuit analysis, whenever you have done in future, what where you are going to use this circuit analysis, this circuit analysis can be used in some device, right? If you are talking about the device, inside the device you have many sub devices or some sub components are there, right?
Yes,
And
in
those,
a PCB, use assemble as to how many things at once. Like that.
yeah, I'm coming to that, just to have
Okay.
patience. So if you talk about that, some part of this device may be having some board. Okay, on that board you may be having many circuits. Okay, these circuits will be printed on this board. That is nothing but we used to say that printed circuit board. Okay, so for example, if I say in your home, means like you are using TV. So if right now we have the LCDs and LED TVs. Before that, it was some big TVs. Whether you have seen or not, I don't know. You
Yeah,
may not be.
picture tube and all that thing.
Yeah,
Like
yeah. Yes, yes, yes. So if you see this kind of TVs back end, some circuitry is there. Okay, and that circuitry is not depending upon the one board. Multiple boards are there. So again, these all the boards are interconnected. How to connect, if we are connecting, what will be the output and all. So this is just higher level thing. But before that, I should know that in means one board, if we have the circuit one, circuit two, circuit three, circuit four, each individual circuit analysis I should do it, right?
yes.
Yes, ma'am.
Okay, so this course is giving you the essence of this circuit analysis. So if you are good in this circuit analysis, next level you can go for multiple circuits together you are using on one board. And what will be the input to the board, what will be the output from the board, and this kind of designing you can do by using your this knowledge. Right. Next, after this board, then all different kinds of board will be there. Same board will not be there. Different kinds of boards, how to assemble to a some device like mobile phone has multiple means
Yeah,
like,
audio system, charging system, and
yes, yes, audio,
display system.
Bluetooth,
Yes.
Wi-Fi, display, multiple antennas are
multiple
used and all
modules.
modules are there. So those kind of things again is coming to that, but this is the base you have to start. Then slowly you can choose your domain, in which domain you are going, then slowly you can, but every domain base is this one. If this is not known, then whenever you're going, you cannot understand how it functions and all, because majorly everything voltage and current you have to deal with that, right?
Yes.
And capacitor, resistance, and inductance. These five are the main things you need to deal with that. But that design, what kind of circuit you're designing, what kind of device you're designing, that is depending upon that to play with these things. And that will be on the chip you are designing and creating the device, different assembling and creating different devices, right? So these are the basics of this course why we are studying. So if you see in the week 9, lecture 1 to lecture 8, some topics have covered. Those topics definitely it gives the background that in future, wherever you are dealing with the communication technology, so these things should be known right now. Also, some few things real means your daily life you are using, so you can understand about that. Let me start about. So for example, if I talk about that, like one signal is there, it has the amplitude and a time period. Okay, like this. Okay,
Yes.
Here we can say that this is the analog signal, and the analog signal means you cannot say that how many times are there. You can say that infinite number of times are there in this signal, right?
Yes.
Whenever we used to talk normally we used to talk that uh, your signal is having this many of hertz. Like for example, one signal is having the 44,100 hertz. Hertz means this many of hertz. If I am saying means people can understand this is frequency based upon the unit, right?
Yes.
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 Okay, so this hertz, if I say that hertz is nothing but 1/second, 1/second is nothing but, or second inverse is nothing but giving you hertz.
Yes.
So that time we used to say that one cycle per second. So here that cycle we can say that, like if we say this is analog signal, so we will just means like take out some small portion from this signal, and that portion can be called a sample. Like you can say, like if you have taken the if you have seen in cloth house, so big rolls used to be there, but you want to show that which cloth
What
you wanted.
material? Yes.
So yes, so then you have to take some small piece of all the rolls, like that is nothing but known as a.
Sample of that product.
Yes. Similarly, here, if you have the infinite time of analog signal, if you would like to analyze, it is not that easy to infinite time you can analyze. That's why I can take some piece of this signal, which is nothing but known as sample. Like, right?
Yes, ma'am.
So these are
Like
nothing but
like
sample.
you are we are speaking.
Yeah.
We always speak. We cannot say all that talking and all that things. Like
Yes, yes. Like,
it
see,
is
means
infinite thing.
whenever I'm talking, some space is there again. So continuously, the signal is coming like this, right? So that
Yes.
means at every time you have the signal, and this is nothing but, if you can say that, up to infinite number of time you have in the
Yes.
continuous domain. That is nothing but analog signal. Whenever you're going to analyze what information is there here, or if you want to store this data, it is very difficult. Infinite time data, how can you store it? Getting it? So due to that, we used to go for the some method which is nothing but known as your sampling.
Yeah, because it's a lot of data to store. Like,
Yes, and this sampling is nothing but we have to take some piece of the signals like this, then we have to analyze again, we have to add all the samples, it will give the whole signal, right?
Yes. Yes.
So how to do it? Randomly we cannot do it. Some process, some method we have to follow it. Okay, so that's why it is nothing but known as your discretizing your time axis. Means with certain time interval, you have to discretize the your time. What does it mean by discretizing? Discretizing
Chote
means
chote part and small
yeah,
parts dividing.
छोटे छोटे हाँ small small part we can take it, like you can say that this is for del t time, you have taken this again del 2 del t time, means first instance if you are taking, second instance, like this you have to take. Okay, so whenever I talk about 44,100 hertz, it says that in 1 second, if you have taken in 1 second, you have 44,100 samples. The meaning of this 44,100 is that. Are you following?
Yes, in 1 second there
Yes,
are
ma'am.
44,100 samples.
Yes. Okay. So in this way, what is the need of that? Like if you see in the lab, we have devices known as oscilloscope. So this is nothing but one screen. And on the screen, you have like this time division, and you can see is some delays there, or you are able to follow whatever I'm saying?
No, ma'am, we can follow it.
No, ma'am. No,
Yeah.
no
Clear.
delay.
I thought some delay is there. Okay. So here, you can see if I give the input to this from my some signal generator, which generates the signal. Like I have selected here to sine wave, so it will be shown here sine wave. So this is
Yeah.
nothing but continuously it will show. So that means it will not capture all the because infinite time period cannot be captured by this oscilloscope, right?
Yes.
So if you would like to store it, then I have to use something on the PC, like computer, and
Yeah.
I have
Storage
to store.
storage devices are thing.
Yes, store. So due to that, we are also preferring this sampling and quantization. I'll come to that sampling and quantization. Is it clear to you? Okay.
Yes.
Yes,
What
yes, ma'am.
does it mean?
Yes, ma'am.
It means discretizing. If you see this diagram, this diagram has this is the time axis, this is the amplitude axis. Okay. So
Yes.
I uniformly discretize means if I start from zero, this is one, this is two, this is three, four, five, six. Let us take like second wise. If you take first zero, it's second, it is there. So uniformly, I have divided the samples, right? So like this 8,000 samples, if it is there, then uniformly I have divided. Then I am finding that 8,000, 0 to 8,000, if I consider this is total is taking 1 second, total time period from here to here is 1 second. That means you have total 8,000 samples in 1 second. Okay. Then what is the difference, time difference between each samples? 1 by 8,000 will give you the difference, that is 125 microsecond, which is nothing but known as a sampling period.
Yes, ma'am.
You
The
understand?
frequency is 8,000 hertz, ma'am.
Yeah.
Okay.
Frequency 8,000 hertz means what? 8,000 samples per
Per
second.
second. Yes.
Okay. That's why I said in 1 second, if you have 8,000 samples, I have divided all the signals in uniformly 8,000 parts.
Yes.
And I can say that what is the duration between each sample? How can I find 1 over
Dividing
8,000?
by 8,000. Yes.
Yeah. Yes. And this is known as your sampling period. This is known as your sampling period
Period.
or
So
sampling
sampling period means distance between two
two
Time
samples.
samples.
time interval.
Not
Time interval
time
between
interval.
Time
Distance,
interval.
yes. Time
between two
duration
signals.
or time, yes. Two samples.
Samples.
Okay,
Yes. Samples.
basically reciprocal of frequency.
Reciprocal of frequency. Yeah, you can say. Okay. So, like you are saying that frequency means this many number of cycles per second, right? Here you are saying this many number of
Yes,
samples
ma'am.
per second.
Okay.
Got it? So, whenever you are dividing, for example, if I have taken this signal, then if I am taking very small this sample period between this, then will it be good? Or if I am taking one signal with a very high sample period, then which will be better? Actually, better one is if you are taking the small sample period. Why?
Yeah. We can
So,
see the small changes between it.
here, small
They
changes
can retrieve better.
as well as if you, I am taking this signal, if I have sampled here, if I have sampled here. So amplitude changes this much, right?
Yeah. We will lose that signal from here.
So not loss. This change is huge. That's why whenever we are going to recover, matlab, means if we are sending the signal from one end to another end, then उस time matlab this will be difficult to get the data. You may
Yes.
not recover this part.
Yes, ma'am.
And
As in
also
the recovery is poor, like it will be distorted.
recovery in the sense what we are generating the signal, then sending the signal from transmitter to receiver, for example.
Ma'am, this is like a sampling is like a storage. When we are trying to store in our pen drive, then also
Uh,
showing this type of graph of filling some things.
yes, good. As well as this, whenever we used to send the signal, also we used to do the
Okay.
sampling, because piecewise, if we are sending, it will be easy to get back also one by one
Yes.
rather than continuous. So, if you have stored this data and this data in between the data you don't know, then it is very difficult to know this data. That is nothing but known as recovery, right?
यस मैम और मैम अगर वहाँ पे अपन पेन ड्राइव में वगैरह जैसे पूरे स्टोरेज ऑफ फिल करने जाते हैं तो पूरी तरह से फिल नहीं होगी अपनी पेन ड्राइव पूरा डाटा स्टोर नहीं कर पाएंगे अच्छे से सो अगर
हाँ,
छोटे छोटे पार्ट्स में अपन ये करें तो बहुत ज्यादा मतलब बारीक बारीक इसमें अपन ये कर स्टोर कर सकते हैं
store
वेस्ट नहीं होगा कुछ भी
barik barik means like see again I'm showing another way.
no
For
when we
example,
take a bigger samples then we lost something so we lost
if I take
space
this sample and if I take this sample just nearby, so the distance between this amplitude difference is negligible, means almost zero,
yes
right? So
yes
that way we are able to get all the values and store it, right?
yes
So that's why it's better to take the more samples whenever it is there. That means sampling uh, rate should be high, right? So one
okay
question I have written here, you just try to answer me. If the sampling rate is 44,100 hertz, then can you find in 1.3 second how many samples are there? For example, I'm saying 4,400, sorry, 44,100 hertz is your sampling rate. That means what? In one
uh,
second,
in
you
one
got
second there are 44,100
44,100 hertz.
samples
So we
Sorry,
have to
sorry,
in
sorry.
one
multiply
second
it by 1.3.
Samples. Okay. Then
yes in one
in
second
1.3 second, how many samples will be there?
we will multiply
44,100
multiply with it
57,000.
samples, right? That means
yes
if we know this data also, we can find the sampling rate also, because this is the sampling rate. Okay.
yes
For example, someone has given you the data of this and asked that to find out the sampling rate, then you can find out this also, right?
yes ma'am
So coming to that, if we go a little bit more detail on that, sample
So ma'am, in
whenever we,
real life, sample is basically a signal.
huh, very good question. See,
part of the signal
A small
I'm
part.
I'm coming to that. You see here, this is one signal, sinusoidal signal. You can see that randomly it is there, right? This is a signal or not?
Yes, ma'am.
This signal carries some information. Just a second, my tab got disconnected. We are talking about that signal. Signal means whatever we are talking, That is nothing but your form of voltage or current signal we are presenting, right? And
Yes,
that
ma'am.
signal again we can represent in the waveform. Signal and waveform are nothing but like same. We can say that this just signal, whenever you say, this is just, we can say that carrying some information. Waveform is nothing but getting some shapes of that signal, right?
Yes,
Okay.
ma'am.
So
To
here,
represent it.
to represent it. So for example, this is my signal, and this signal, whenever I'm saying that this is in the time domain, but in the sample, whenever we say that in the time domain, this t is the continuous. I used to write x of t, and all the informations are in this signal. I want to know particularly at t equals to 2 second what is the information is there, right? So
Yes,
how
ma'am.
can I
That
do?
is sample.
So that is sample. So that's why we are dividing the time axis into number of time slots, and each time slot is having some amplitude value, that is known as here discretizing the time axis. Discrete means what? Single value. Okay.
Okay, ma'am. Like
Time.
what we do, like with equations, we put value of x and find value of y. Similar to that.
Here you, it is not x and y. This is my time value. If it is 120, at 120, what is the value x of 120?
Ma'am, X is the amplitude here.
Yes, x is the amplitude here.
Okay.
And this amplitude is written in form of, amplitude is the function of time, because amplitude depends upon the time, which time what amplitude is there, because
Yes,
here
because
based
it
upon the
is
time.
not a continuous signal.
This is a continuous signal. This black one is a continuous signal. And
Okay.
whenever I'm showing these blue lines are the discrete signals.
Yeah.
These blue lines. Okay. And this discrete signal separately, if I draw, then it will be like this. Are you getting?
Like a
So this
graph.
will be, you can see now, this is the discrete signal.
Yes.
This red lines.
Yes.
So this is discrete signal. This black one is the continuous signal. And we are trying to convert this continuous signal to this discrete form.
Yes. Because we
So
cannot
for,
store that continuous signal.
yes. So that's why how to convert it? By using the process of sampling. And how to do the sampling? We have to divide the time axis into the number of time slots.
Yeah.
And each time slot, we have to see that what is the amplitude values are present. Got it?
Yes.
Yes, ma'am.
Now you can see that here x of t, if I have written, this is the continuous time signal. X of nts means number of time sample times are there. If this is ts,
Yes.
this is 2
With respect to time,
ts.
how many samples are there?
So here try to understand this t I have divided into the n number of time slots, and this time slot is nothing but sample time.
Yes.
Ts
Each
is
sample
constant.
time, each time, yeah, this is constant. This is nothing but duration between two samples,
Okay.
and you have n number of samples. Then total time will be the n number of samples multiplied with the sample duration. Got it?
Yes, ma'am.
Yes, ma'am.
So if I'm writing x of t can be written as x of n of ts. Are you following?
Yeah,
If
got
I
it.
Yes, ma'am.
know the ts, for example, ts is equals to 1 second, 1 second or 1 millisecond, whatever I've taken. So now I need to find out the what is the 1 second, what is the sample value. This is the amplitude value. That means it will give you the amplitude at particular time instance. So ts 1 second means your first sample value one, first sample n equals to 1, That first sample will be at 1 second, right? So here it is started with 0. That means first sample is taken as 0th sample. Then first sample like this. 0th sample if I am taking, n value is 0 means 0 multiplied 1, 0, x0. Then n equals to 1, 1 multiplied with 1, x1. Then 2 multiplied 1, 2, x2. Like this, all the samples will be extracted. Now you tell me this x of 0, x of 1, x of 2, are they dependent on the time right now? There is no time. Values are here, right? Because previously you were writing x of t. Can you see?
Yes.
So that means we can say that this is only the like particular values you are getting some instance. They are not dependent on the time. That means you can store it easily. Is it clear?
Yes, ma'am.
Ma'am, I'm confused in the formula.
Formula, what is the confusion? Tell me.
Yeah, TS is the time of a samples of one sample.
See, TS is nothing but this. This is your TS. This is, if I've said, this is your 0th sample. This is first sample, second sample, third sample,
Sample
fourth
third.
sample, fifth sample. So this TS is difference between each samples and which is constant.
Okay, different yeah, time constant between the signals. Uh, Discrete signals.
See, discrete signal. If I
So, ma'am,
say
it will
this
be constant always.
yes, this is nothing but sample duration. Means each sample
Okay.
because the time slot, the time axis, continuous time axis divided into equal number of intervals. And
Okay.
each interval is TS. This is 0th interval, this is first interval, then this
Yeah.
will be second interval, but each interval is having the different amplitude values, right?
Yeah. Amplitude is different, but time is
Time is
similar
also
with.
time is different. Difference
Okay.
between the time duration, first sample to second sample, same.
Yeah.
Let me take an example here. So for example, I say this is a 1 second, 2 second, 3 second, 4 second, like this it is going on. And this is something 1, 2, 3. 1 volt, 2 volt, 3 volt. Okay. So for example, 1 second I have one, and 2 second I have
Ma'am, ma'am, screen is little bit lagging.
now is it fine?
Yeah, means lagging means you write first and after some time it will show on the screen.
That only I just asked before. Now it is fine. You can see.
Yes.
So you can see here in 1 second means what? This 1 second to 2 second, what is the duration? 1 second. 2 second to 3 second, what is the duration? 1 second.
1 second. Yes.
Okay, that this is nothing but TS.
Between distance between two discrete signals.
Distance, not time difference or time
Time difference.
interval.
Yes. Time
Okay,
difference between the two discrete signals.
yes, that is
Okay.
nothing but your TS. So whenever I am writing, this signal was x of t. X of t I was writing. This t was continuous. Always I have to
Yes.
write x of t in terms of t. Whenever I am discretizing, this x of t can be written as x of n of ts, where ts is constant. I have taken here 1 second. N is nothing but number of sample numbers.
Yes.
Okay.
So
So
sample number
here,
is nothing but the frequency.
no, this is the first sample means 0th sample, first
Yes.
sample, second sample. So n equals to 0, n equals to 1, n equals to 2. Like this it will
Okay.
go on. So I can write here x of n ts. I can write it is nothing but x of n means 0th sample, ts is constant. So I don't care about that. 1 second I have taken x of 0. Then next sample will be x of 1. Next sample will be x of 2. Like this, it will be going on. Is it clear?
Yes, ma'am.
Any doubt is there?
Clear, ma'am.
Okay. This is known as your dividing your time axis into equal interval and finding out the corresponding amplitude value. This is nothing but known as sampling. Sampling always deal with your time axis. Okay.
Yes. And
So
amplitude
each
also.
amplitude, I'm coming to the amplitude. For example, this is one signal. You can see
Yes.
x0 is the first sample, or I can say 0th sample. X1 is the first sample. X2 is the second sample. Okay.
Yes.
Now you can say that, for example, 0th sample has the amplitude value of 1.2592, like this very big value. It is also difficult to store.
Yes.
X1 also is having some big value. It is also difficult to store. Then how to store it again? That's why we need to
We can round it off.
not round up. That rounding, not normally, that process is nothing but known as quantization.
Yes.
Quantization means what? This comes from the word quantity. Your amplitude is giving you the quantity, right?
Yes.
So when how you have divided time axis into the equal interval and you got the samples, each sample is carrying what value, you can get it by sampling or by discretizing your amplitude axis. That discretizing the amplitude axis, that process is known as quantization. Discretizing the time axis, that process is known as sampling. Is it clear?
Yes.
Yes.
Means if in question we are asked what is like calculate quantization.
Yes.
So
No, calculate quantization it will not be. Calculate
okay.
the quantization steps it might be. Quantization will not be. Quantization is the process.
Oh,
Yeah. Is it or
and so
not?
it means discrete time intervals means sampling, and discrete amplitude means quantization, basically.
Yes. Yes.
Time sampling, amplitude quantization. Right.
Sampling and not sampling we are saying, but we can say that discretizing the amplitude. See, discretizing the time axis is known as sampling. Discretizing the amplitude axis is known as the quantization. Why the
Quantization.
name is why the name is quantization? I said the axis y-axis carries always quantity or
Quantity.
value, and time axis is giving you the at what time what uh, sample is present, like of what number means you are normally I said that no, like a 0th sample, first sample, like I said that whole signal is that some piece of the signal you are taking, that piece how to define that piece is nothing but known as sample. But that piece or that sample is having what value, that will be given from the quantization. Is it clear?
But
Yes,
ma'am,
right.
value will not be uniform like in of the
No,
signal.
no, the value, like I'm coming to the quantization process. If you say, for example, my signal X mean is 1.2 volt. Is it visible to you?
Yes, sir.
Yes, ma'am.
X min is 1.2 volt, and my X max is 2.5 volt. X min, X max means what? If I say that this is my signal and this this is my x min, and this is my x max. Okay.
Okay.
So this is nothing but carrying all the amplitude values. These are all the amplitude values, right? So these amplitude values will be divided into the equal number of levels. And the question is that why equal? Non-equal also you can do it. That some technique is there, but for the timing you understand equal number you are taking for analyzing, means easily you can analyze it. Okay. So, in the sampling, you have taken equal number of time intervals. Here, equal number of your levels you are taking. So, first level is 0th level, first level, second level, like this. If that depends upon if your number of levels are increasing, your quantization will give you better value. If number of levels are reducing, the quantization will be giving the not accurate value. Why? Because already I have shown you that this point and this point has much difference. If you quantize this to this, definitely close values you are getting, easily you can get back it. Are you getting?
Yes, ma'am.
So
What
here,
is
for example,
levels here?
this levels are nothing but for example, I say I told you here 1.2 volt to 2.5 volt means this is totally 1.3 volt. This total value is 1.3 volt. This
3 volt. Yes.
1.3 volt equally divided, and each division, whatever say, these lines are known as levels.
And so when
Okay,
we divide
Okay.
1.3 with these levels, then what we will get?
you can see here, if I'm taking, this is my
Like, ma'am, if we divide 1.3 into 10 parts, so it will be first level,
huh.
second level, third level, like that.
Yes. I'm
Okay.
saying here, you can see this is 0, 1, 2, 3, 4, 5. So you have 6 levels. Here it is 1.2 volt, it is 2.5 volt. So now you can say that this is nothing but 1.3 volt, right? 1.3 volt has divided into equal how many parts? 1, 2, 3, 4, 5 parts, right?
Yes.
Yes,
Yes.
ma'am.
Yes, ma'am.
Then
Then
you
so
are
labels
getting
will be 6.
each level difference. How much you are getting? 0.26
1.3 by 2.
around.
Zero point.
1.3.
0.26 volt around, right? So
Okay.
that means
Okay.
each this quantization level first, this quantization level difference is 0.26 volt, 0.26 volt, like this. Are you getting?
This is a level
Yes, ma'am.
0.26
Yes,
volt.
ma'am.
Okay.
Okay, that means if I'm saying this is 1.2, this will be 1.246. Then next will be 1.26 is the 672. Like this, it will be increasing up to 2.5.
Okay.
So if you see difference between this is 0.26, difference between this is 0.26, like this. So
Okay.
if I have shown here, if you have taken, this is one sample, that sample value, whatever it is there, and this is another sample. I can say that this is nth sample, this is mth sample. This nth sample, mth samples amplitude values are much different. If I take quantization, then whatever the values I am getting, that values previously, whenever I was not doing the quantization, I was storing in the very large value. If I have done this quantization process, what I can do, I got this difference value. This difference value, I can level it like 0, 1, 2, 3, 4, 5. So I can store in the 0, 1, 2, 3, 4, 5 in this way also. Later on, you can also more know about, we can convert it to the binary also. So we can reduce the storage space.
Can you, ma'am, explain it again? Like after dividing into equal parts, what will be?
So see here in this figure. So for example, your x was like 2500 millivolt. 2.5 volt is nothing but 2500 millivolt. You are starting from 1.2 volt means 1200 millivolt, for example. Okay. So here, if you take uh, this is your first sample, means sample, forget about actual amplitude value was 1200 volt. Next, if you are going, then it will be giving you 1210. For example, I have taken 10 millivolt of difference between each quantization levels. Okay, this is giving you 10 millivolt. This is giving 10 millivolt. This is nothing but the notation is used delta. Delta or del is nothing but 10 millivolt. That means difference between each quantization level is 10 millivolt. Got it? So whatever the values you are getting here, the difference delta value you are getting it. Okay. So now you got whatever the value, that value can be converted into the binary form next. Then you can store it in the uh, either 2 or 3 bits. If it is not also, I can say that this is my 0th quantization level, this is first quantization level. So that means I am saying level 1, level 0, level 1, level 2. I can store 0, 1, 2, 3, 4. That means only one digit I am using to store the values. And this 0 is nothing but carrying the 1200 millivolt. Are you following me?
Yes, ma'am.
So
Yeah,
in this, so the bigger picture, if I say, the bigger picture, if I take, this is my one signal. Okay. Together, if I see, like
so
I
ma'am,
am doing,
by by retrieving back, so we will say like 1200 into 1 into 10. Oh, sorry, plus 1 into 10. So
yeah,
1200 plus 2
1200,
into 10 like that.
1210, then 1220, then 1230, like this, you are getting the values.
Levels
Oh,
of levels.
Yeah, level values, that quantization values. Previously, randomly we were getting, and it was very high values, high decimal values. So just see here, I'll just repeat again all these two process. This is my time axis. If I take in the time I have taken, this is TS, this is 2 TS, this is 3 TS, this is 4 TS. Like this, it is going. Each sample has some like amplitude values. Okay, this amplitude value in the beginning it was taking. For example, I can say this is 5, this is 6, this is again 5, 5.33, then it is 4.5567. This is taking for example 3.11546. Like this, these values are there, right? So whenever I started, someone has answered that we can round off these values. Then we can say that the storage will be reduced, right? This rounding off, if you see in technical term, here that in the signal we are saying that quantization process we have to do. What is that quantization process? Now this, all these amplitude values we have to divide into the equal number of parts. Okay, that means based upon this equal number of parts, I can say that my amplitude of this sample was this one. Okay, now increase to this. Like you can say this to this, there is no change from this sample to this sample.
Ma'am, are you writing?
Yes,
is it lagging, ma'am? I think.
Yes, ma'am.
is it right, Laggy?
Yes, ma'am.
Can you write
Nothing.
once? Like,
So
Nothing
you
happens
can
on a
see,
screen. Yes.
you can see from here to here.
oh yeah,
Blue
yeah,
line
it's
I
clear
have
now.
drawn.
Now it.
Yes, now fix.
So you can see that from this point to this point, you can see that there is no change in the amplitude. Then at sixth only amplitude change you see. Then six to this point there is no change. Again the change is happening here. Again here to here there is no change. Again the change happened here. That means when the change is there, that change I can denote whenever it is constant. Like I can compare this value to this value. This is lesser, that means 0. This is higher, that means 1. Somehow like 0 1 form I can compare and
Okay.
assign it. Are
At
you?
the 4 it is 0, ma'am. Like it is decrease.
Yeah, it is lesser, it is 0. It is lesser, it is 0. Again, it is higher than this, I can assign 0. It is higher than this, not 0, sorry, 1. Means
Which is
if you,
one?
the 5.33 is higher than 4.55, right?
Yes, but it is smaller than 6.
No, I'm just comparing these two corresponding points, consecutive points, not the, right? So that means I can see that from this step to this step, whenever I'm coming, the value remains constant up to this. Suddenly it gets this value. That means it decrease means from constant values to it decrease means it is I can say that 0. If it is increasing, then I can say that 1. Are you getting or not? If 5 to 6 it is increasing, 1. Means this is, I am saying, I am assigning 1. You may assign 0. This
Okay.
is somehow we are coding.
Ma'am, here we had to mention from the direction also because
No, no,
if
no, no. This is random. Means, see, if I am doing the quantization process, this is your zeroth level of amplitude, first level
yes,
of amplitude, second level of
second level.
amplitude.
Yes,
Okay, this to this, some difference is nothing but delta I said. Okay,
yes,
so from this to this, the amplitude remains constant.
yes, ma'am.
Okay, so whenever this is increasing, I can say that this is 1 1. Whenever it will start decreasing, I can say that 0 0. If I am assigning 1 1 0 0, you may assign 0 0 1 1, right? Because whatever your comments coding is there, accordingly you have to store it, because ultimately the system will, whenever it will store, the user knows that in which form I have stored it. Are you getting or not?
In which
Are you
form means,
getting?
ma'am? In binary or in a decimal,
Yes,
like
ma'am.
a
In binary only, binary only. That's why my main intention was that to save here. I said 1200, 1210, 1220. So you can see that increasing happening 10 millivolt. I said na, you may do some coding after that. The code maybe you can say 0 1 2 3 4 5, but 0 1 2 3 4 5, if you're taking binary form also you can convert. And the binary is nothing but you can say that if it is increasing 1, decreasing 0. That
yes,
means you can say that somehow you are comparing the two values.
yes,
Are you
ma'am.
following me? So
Yes,
this comparison will give you either 0 or 1. That means whole bigger value can be stored in form of, so I had shown this here, in either 1 or 0 form. That means the storage space will increase or not. Is it or not? Are you following?
ma'am.
Yes, ma'am.
How the storage
So that's why this quantization is required.
ma'am, storage increase or decrease? It is depend on.
No, we are doing for storing the data, this
Yes,
sampling and quantization process, right?
yes.
So finally, we can store the data by using this sampling and quantization process.
Yeah, we cannot store in a decimal form. That's why we are using a binary form of it. Like if it is increased, then we take 1. If it decrease, then we take 0.
Either or, vice versa also you can take, but increase, decrease based upon whatever I'm saying, that is nothing but comparing the levels. Level, two levels will be compared and some code will be assigned.
Yeah. Means how many difference in each level.
How many
So
differences means, like, see, I have to go for two level comparison always.
okay, first level and
Then
or
this,
even zeroth level or first level.
then first level, second level, then second level, third level, fourth level, like this. Then I have to
Okay.
assign some values to those levels before, because why? You can see here, I have 1.2 volt. Then I can say that 1.3 volt. Then I can say 1.4 volt. Like, so I can see that my, means like, the steps whenever I'm making, the steps are increasing like this. So here I can see that 1.3, 1.2, 1.4, it is not required to store. I can store in the, by comparing 1.3 to 1.2, it is increasing 1. It is increasing 1. Whenever it will start decreasing, then I can assign 0. Are you getting or not? That means always two consecutive values are compared, or two consecutive levels are compared, right?
Yes.
So overall, if you see that we are doing, the xt is applied to the time quantized, or we can say the time sample. You are doing the quantization in time. If it is, that is nothing but known as your discretizing time. That is sampling also. Different terms we are using. Okay. But amplitude quantization you are getting. Then finally you are getting the your sampled quantized signal. Okay. So this process actually, wherever we are doing, we can also say that this is sampling and holding the values. You can see that here, if 0th sample, you can see in the diagram I'm just writing,
Yes.
and this is first sample. Then I have second sample. Then I have third sample.
Yes, ma'am.
Then I have fourth sample. Then I have fifth sample. Then I have sixth sample. After some time, it holds the value. So that means the sampling and quantization, whenever I did in quantization, it samples, then hold the value for some time, then sample, then hold the values for some time, sample, hold the value for some time. So sample and hold operation is happening also. Are you following?
Yes, ma'am.
Yes, ma'am.
So if you come to now, whatever you studied, these are all signals related. How can you relate to the circuit? Coming to the circuit. So sample and hold, can you say that, like, I want to store the value for some time, then I can use capacitor? Is it or not?
Yes,
Yes,
for
ma'am,
some
ma'am,
time.
because is used for storing energy. That's why.
Yes. So capacitor can be used for the storing that value for some time. For xt is there, xt I have sampled it. This switch will, what this switch will do, switch is open means no
Uh,
value is passing
yeah,
here.
there is too much resistance. Yes.
Ah, so infinite resistance. You see, for example, I have sampled this TS period. Okay, that means I have just to close the switch, store this value up to this. Okay,
Yes.
next I have opened it. Opened it, I have gone to the next level, amplitude. Then I have again closed it. Then stored this value up to that. Then I have opened it. Then I went to the next level of value. Then I have closed
Yeah.
it and stored the
Because
value.
capacitor needs some time to charge, so we will when we close the switch, it will charge by one level, then second level until it fully charge, and then we connected resistance to it, then it will discharge one by step by step.
Here actually charging and discharging, whenever you are saying resistance is required. So
Yes.
without, we are just assuming that this switch is
Only
having
battery
some
and
small
switch. Yes.
resistance. Yes, battery and switch, some small resistance is there. Based upon that, we are saying that. So it holds up to some time. Due to that, you can see that your steps are like this whenever quantization level you are doing.
Yes.
Okay. So like you can see that this control signal is given to this switch, means the control signal will be like this. So that means you're holding the amplitude value for some time. Then next sample period, again it takes the another amplitude value.
Yes.
Okay. So this is whenever you did it. Finally, whenever we would like to see that this is happening based upon the comparison. Okay, like you have the high VDD value minus VDD value. If you see that low VDD value means I can say that this is 0, this is 1, right? Means finally you are comparing two amplitude levels and assigning the 0 or 1. Is it delay?
Yes, ma'am. Lagging and screen is
Yes,
showing
ma'am.
blurry things.
Yes, ma'am. It is that.
Yeah, now it's fine, I think.
Uh, now it is.
Yes, ma'am. Now it is.
Yeah, this is just your means difference between the two amplitude values. You can see that lower amplitude value 0 we have assigned and higher amplitude value 1. We're
One.
just
Yes.
comparing these two. That means some comparator can give you this storage output, right?
Yes.
So if we go flash ADC, an electrodigital converter, means we are giving the input as the analog signal x of t.
Yes. Flash ADC.
Uh, I'll come to that what is flash ADC. First, understand the circuitry, then I'll tell that why the name is that. So x of t, if you are giving the, you know that like comparator, if we design some comparator means this is nothing but operational amplifier which is having the non-inverting terminal and inverting terminal. I think you have studied in some other course.
Yes, ma'am. Akalle ma'am take this part in the previous session.
Yes,
Yes,
ma'am.
yes. So here you can see that X max, for example, your maximum voltage level is 4 volt, for example. Okay.
Yes.
So here you are designing whenever you have to compare 1 volt to 2 volt, 2 volt to 3 volt, 3 volt to 4 volt. Minimum voltage is 1 volt and maximum voltage is 4 volt.
4 volts. Yes.
So you have to give all the levels, like quantization level values. You have divided the amplitude into the equal levels like 1, 2, 3, 4. Okay. Then
Yes.
each will be given to the inverting terminal of the amplifier, operational amplifier, and all the positive or non-inverting terminal are shorted. So in this way, if you are arranging the circuit, so what will happen? For example, this is your first sample. First sample has the 0 level, second sample has the first level, third sample has the second level, and fourth sample has the third level. Okay, so here you can see that 1, 2, 3, 4 volt I have given, and these registers are there. For example, this R is there. So based upon this, we can see that if we take all the output and add it, then I can get all the quantized signal. All this signal I can get it. How is it possible? I first compare. Means let's find it out. Like my x of NTS means my sample. I have, for example, randomly I have taken some sample. That sample value is 2.75. Means one sample in my signal was 2.75 volt. Okay, this sample value I want to store. Okay, so this sample value I will be storing in the form of quantized signal, because quantized will give you the digital data. Okay, so or discrete data. So in that case, for example, 2.75 is my sample value, raw value. I need to do the storing, that means quantization I have to do. So what I will see, 1 volt is lesser than the 2.75 volt. Let me assign 2.75 is higher than the 1 volt. One I have assigned. 2.75 is higher than the 2 volt. One I have assigned. 2.75 is lower than the 3 volt. Zero I have assigned. That is nothing but VDD, VDD minus VDD. Then if I pass through some summing, amplifier or adder, then it will add and it will give you the that sample x of nts samples quantized value. That means 0, uh, 0, 1, 1, right? Huh? So this way you can use. So what is the meaning of the flash ADC here? So ADC means what? Analog data. This 2.75 was your analog data. It's
Yes.
converted to the digital data. And why it is flash? Because it stores for short time. That's why its name is flash. ADC, and it is the very means like general ADC to convert it. So that's why people used to start with this flash ADC.
So
Ma'am,
ma'am,
here
it is
we
a
take your
circuit.
fixed voltage of 2.75 volt and compare with it.
Compared with all the levels, the
Yeah,
quantization levels.
yeah,
Okay,
3, 2,
then
and
you are, yes, this is what you can see that this is the design. This is the circuit design. Whatever you understood here, you can see that this quantization I have explained here, this quantization in the figure. Just a second, it is
yes, ma'am.
lagging.
Comparator, I understand. I want to just recall that topic because ma'am taken that day, and it will be helpful to recall, ma'am.
Yeah, yeah. This is theoretically you understood what is quantization, what is sampling. But if you want to convert this to a circuit, that
Yeah,
circuit design is nothing but here.
yes,
So
ma'am. I
Whatever.
basically,
understand the
that
circuit
is a
also.
practical example of that.
Yeah.
Is it clear? Now it is like you are able to breeze that how the signal and all these things related to the
Yes, ma'am.
circuit and all, because I started with that only, right?
So ma'am, this circuit is comparator or ADC?
This is ADC. Each individual, these are comparators.
Comparator who
Okay, okay.
compare 2.75 volt with that.
Okay,
See,
so
to 2 points.
2.75 is our input and it will be compared with 1 volt, 2 volt, 3
Yes,
volt,
yes,
and that
yes,
analog will be
yes.
converted to digital like 0, 1, 1, like
And
in
ma'am,
One,
binary
if
one.
if,
form.
if
Yes.
input is greater than that,
You take any value here. 5
yes,
volt if you're taking. So 5 volt is greater than 1, 1. 5 volt is greater than 2, 1. 5 volt is greater than 3, then it will be 1.
one, yes,
Right?
So ma'am, we will
So,
get binary output.
yes.
Okay.
Is it clear?
So ma'am,
yes,
if this flash ADC is basically this flash ADC is a practical example of what we learned above
Huh.
implementation.
Yes, yes. Sampling and quantization ultimately is required to convert the analog signal to digital.
So ma'am, 2.75 is basically, for example, analog, and
Analog signal.
0, 1, 1
Yes,
is digital.
yes,
That's right.
yes, yes, yes.
Okay, ma'am. Understood.
Okay. Is it
yes,
clear for everyone?
yes,
Yes,
ma'am.
ma'am.
Okay, then thank you. So let's see next, and you just try to means inform your friends to join
Yes,
the sessions. Okay,
Yes, ma'am. Thank you, ma'am.
okay,
ma'am.
thank you.
Please, the
Ma'am,
Yeah,
previous session is not recorded, not uploaded on the YouTube and that playlist. Can you?
this I will just inform Akalya.
Yes, ma'am. Thank you, ma'am.
Thank you, ma'am.
can you take few questions based on week 9 and maybe next session? Just a couple of minutes, I guess.
Pardon?
Maybe can you just take a few questions like in the next session with respect to week 9? In
Yeah,
next session.
yeah.
Okay, okay, thanks.
Can we leave?
It's over.
Okay.